Hello, welcome to this video. So in this video, I'm actually, in the last video, we were talking a little bit about how to programmatically get existing task names in NI-DAQmx. And then, we were able to get all the existing task names. So I think, that was what we discussed the last time. And since then, I've played around a little bit more, and I've added some functions that actually test different things. So yeah, okay, let me undo. Okay, where were my functions? Yeah, I think when we get a task object, or we have this get task names. All right, so let me import Python NI-DAQ self equals to Python NI-DAQ workspace. Okay, then test object equals self.get test object. Okay, and then okay, I think also we can get the NI-DAQ object if you want. Okay, I'm going to do a little bit of a print here so that I can remind myself. Okay, to get NI-DAQ object use. Okay, and I'm going to do the get NI-DAQ object. Okay, so I'll just say NI-DAQ object equals to self or test object dot get NI-DAQ object. Alright, then that should about do it. Let me get the test object again. Where's line 156? Yeah, I think I've pasted some things by accident. Print NI-DAQ object. Oh. Let's escape. I'm going to search / print star IDAQ object, or rather have this wrappers thing. There's line 156. Oh dear. Okay, line 156. 156. And then NIDAQmx wrappers. Ah, there you go. There you go, there you go. Okay, so NI-DAQ object equals to test object dot get NI-DAQ object. So where's that end print? Oh my goodness. End print. Oh goodness. Pardon me, I think I keyed in too many wrong strokes just now, so finally. Okay, so yeah, that's what we get, and I can get my task names and I can print. Okay, NI-DAQ object or task names equals to NI-DAQ object dot get task names. Okay, so print task names, and you'll get this. Okay, so what I found out also was another way to get to so-called get our task objects. All right, right. So-called we were stuck at getting our task names. Okay, we will start getting our task names. Okay, this one's called module 8 temperature reading, my temperature task, and my voltage out task. All these will be depending how you configure it inside your NI-DAQmx Explorer, or yeah, then you have these different tasks. Of course, you can create tasks over here as well, and that's fine. But previously, I think in my last few videos, we saw that the output was kind of blank. Now, I did a lot of debugging, and long story short, I found out that I forgot to print the output. So that's why there is some sort of error. Okay, so yeah, hold on. 547. So I want to say the task actually works. So let me show you the test, alright, and explain the code to you very quickly. So I have this test task, and well, what's test task? Okay, test task is just getting the NI-DAQ object. We build the system, we return the task object. Okay, what's the task object? Well, if you see this, task object equals to NI-DAQ object, not return task object. Okay, and what happens? Okay, print task object. And for task, task object is just an empty task. So if you take a look here, get task objects, or rather return task object. Okay, return task object is this one. It's just creating an empty task. So so what happens with this empty task? Okay, we print the type of the task object, and then we print the task object itself, and then I add a thermistor channel, temperature sensor 1 AI7. This one is manual. Then I read the task object. Okay, so what happens after I read the task object? I store all the data in this reading file. Okay, I store all the data in this reading file, and then what happens? I need to print out the reading file in order to see the output, and I need to print the type of the reading file. Okay, so ignore the for loop first, but yeah, I'm just saying that I need to store the data into this thing called reading. It's a literal reading, of course. I print that reading, and I print the type of reading, and then I need to actually perform some cleanup, which is to close the task object. Now, there are of course a lot of concepts that I haven't gone through before, such as the closing part, and then it's basically the closing part, and then why do we need the closing bits? So, well, we will just try to execute this code first and see what happens. Okay, test object dot test task. Okay, and look what happens. So if you look at this code, I actually run this reading of the task object 100 times. So you can see that the temperature actually is fluctuating up and down, almost like a sine curve. So it's going from 30 all the way down to 15. So what's actually going on behind the scenes? Okay, whenever we have a virtual instrument, all the channels are just receiving sine waves by default. You don't need to create some custom task as we saw through NI-DAQmx in order to see this sine wave. You can actually just what do you call that? You can actually just make a new task within the NI-DAQmx, and then you start reading the channel, the physical channels, and actually all the physical channels will be, as long as you are reading it, it is actually putting out these sine waves. So they are actually going to store and give you some values here and there, right? So that's but if you kind of don't do this for I in 100 thing, okay, so let's see, print first read. Okay, print reading, then Yeah, so what I'm going to do here is that I'm going to print the first reading from this task object, and then I'm going to print the subsequent readings. Next, we read the task. We use the task object to read readings 100 times. Okay, so that's what we are doing. So let's get the task. Let's get this test task again, and then we will. Where is the test object? We will get the test object, and then we will get the test object dot test task. So okay, we will read 100 times, but you notice that the first reading is always this number. If I run this test task again, okay, if I run this test task again, then I will always see this first number, like 33.672 something. Okay, so what does that mean? Okay, so it means that like I said before, every time you start you start reading you start reading a virtual or a simulated DAQ or simulated DAQ physical channel. Yeah, then the moment you start the task, it will start putting out this sine wave, and the sine wave will always start at the same place. So for example, 33.67 something, and it will of course change from time to time, but the simulated signal will be such that it will always start at the same place. Okay, so that's something you need to know with simulated DAQs. Okay, so next question is, why do I have a task object close? Okay, so remember last time we actually had this task is busy. Okay, so let me try showing you if I don't close it. Okay, you may or may not get a bug if you run it twice in a row. So test object equals self.get task object, and then I'll run the task once. I'll run the task again, and then what does it show you here? Okay, blah blah blah, resource warning, name of task was not closed before it was destructed. Resources on the task device may still be reserved. So this is a warning basically. And what does this warning say? It says that it says that because we did not delete the task thing properly, the device may still be busy. So okay, let me try to put it out for you here. And okay, so let me use this. Okay, let's say we have a task like device 1, right? Let me try to write device 1, and at first you will have a task. Of course you make a task object, you make device 1 do something, so you get task 1, and then you start reading. Okay, you start reading, and then you read and read and read and read, and then let's say once you finish this object, this task 1 is supposed to not read anymore. You want to like do away with it, right? So when I started to do that, okay, when we actually run this test task again, I'm actually making when I run this test task object twice, what I'm doing is that every time you run this, you're actually making a new task object. So this task object may be called task 2, and then it will start trying to read this again. Okay, now if task 1 actually closes properly, then device 1 won't be busy, and then task 2 can use device 1. Okay, and device 1 or physical channel being this temp sensor AI7, right? In this case. So what you're supposed to properly do is to quickly delete. Once you finish reading, just delete the task so that you make space for a new task to start reading device, this physical channel. And then so that's what this warning is for. Okay, that's what this warning is for. Okay, so let's say, okay, for example, I interrupt this code halfway, and let's see what happens. Okay, I will interrupt halfway and then I'll try to run again. Okay, okay, in this case it seems okay. In this case it seems okay, but I don't know, I've run into bugs before. Okay, long story short, I've run into bugs before, and if this thing doesn't work properly, okay, I think I know what to do. Okay, so let me force this program to have an error. Print ABC. Okay, because ABC is not defined. So let me try to run this thing twice. Okay, I need to reload the thing. NI-DAQmx. Test object is loaded, and then let me load the task. Let me test this. Okay, test object dot test task. Okay, it says what ABC is not defined. All right, but it's able to do the first reading. Okay, you'll be able to do the first reading here. Okay, and then of course the first iteration of I will be okay until you hit this print ABC. Then of course the code doesn't know what ABC is. This is done on purpose to interrupt this thing. So let me try running this again. Okay, I was not able to repeat the error. Okay, this is not as planned. Okay, maybe a better way to show you, if I can so-called do this, then I will still use the task object close over here. But what I'll do is this: I will start the reading of this task object, and then of course I'll print the reading, and then I will have a second task object. Task object 2 equals NI-DAQmx return task object. Okay, so let's say I read this thermistor channel once, and then I try to read again. Okay, I try to read it again by having another task object do this reading. Reading equals task object dot read. Okay, print reading. Yeah, I'll say task object 2 dot read, and then print the reading. So this one will be second read. All right. So I'm showing you. Okay, that. Let me get the test object, and then we'll run the test task. And then what happens? You see this specific. Okay. Okay. There's no channel on this task. Okay. I need to add a channel first. So I'm going to copy this and paste it here. Task object 2. Okay. It will say that the task object is busy. Okay, let me reload and then test task. Oh, okay, this is interesting. Okay, I did not expect that to happen, but apparently this thing works. Okay, so yeah, there are two task objects that are so-called reading this thing. Oh, I think I know why. Because this task object is actually reading the thermistor channel, the temp sensor 1 AI7 one time, and then it shuts off. Then task object 2 reads this channel one time, and then you read it and then it shuts off. So you don't have this kind of issue. Now, if you have a continuously running task, for example, this task object 1 is continuously running, then you have the problem of, conflicting resources. So if in that case you do have this issue, then you need to explicitly close the task. Okay, you need to do this task closing. But I think in this video I cannot really show you just yet what's going on. It will take another video. So I will just delete this thing, and let me undo, delete. okay, I'll just delete this delete this thing, and I'll just say, yeah, this test task line of code actually works. I'll not do anything else with it. Okay, so but yeah, I see you have this thing, resource warning, a named task was not explicitly closed before it's destructed. So you have this thing. If you don't want to see this error, then of course best is you always close your task, right? Always close your task. If not, you will have stuff like that happening. Okay, but for now it works, so that is fine. Okay, so I guess the close thing I will explain in future. If the errors come, I can show you why this is needed. But for now, just take it that you need it, and then just close task every time. It's a good habit. Once you're finished reading, just close the task. Okay. So yeah, long story short, we are able to get a reading. Okay, but along the way, I also was doing some debugging, and then I also learned a lot. Okay, for example, this one is called test read existing task, right? Test read existing task. So let's run this test. Test read existing task. Yeah. Let me see. 2125, right? 2125. Test read existing task. Alright. And then yeah. What's actually going on here? Okay, this thing actually runs well, and I can run it again, it will still run well. Alright, so what's actually going on here? So remember in the last video, I actually wanted to show you how to get the task names of each of these existing task objects in NI-DAQmx. So that's what you do with these first 3 lines. Okay, so how do you, well, based on the name, can you then get all these task objects which are already in NI-DAQmx that you set it up that you have set up properly? Answer is not quite. That's not the way to do it. I found that the way to do it is a lot simpler. If you take a look at this article, it says that we can access NI-DAQmx tasks from NI-DAQmx Python library. The only thing you need to do is to go to the local system. One is that you can get the task names, or okay, you look at this thing called persisted task. Alright. Oh, right. Okay, never mind. Yeah. So looks like they do get the task name first. Okay, you do get the task names first. Okay. Okay, you do get the task name first. So for example, p task equals NI-DAQmx system storage persisted task. Then you kind of put in the task name over here. Okay, or since this thing is a list, you can just access the first item of the list using system task name 0, which is this whole line here, and then you sort of use that as the input to this persisted task. Okay, there was a lot of confusing things, but let's slow down a little bit. Okay, so far I have shown you how to get the task names. Okay, so okay, I guess according to the NI-DAQmx article, you can use these strings. You can use these strings to actually access the relevant task. The way to do it is as follows over here. You put over here p task equals NI-DAQmx system storage persisted task with the underscore, then persisted task. So this is a function underneath a lot of classes, I don't know what, but the input you take is this text file. Okay, in this case it's my voltage task 0, as you can see here. All right, so you can put in the string manually, or you can also save this list into an object, and then since this is a list object, you just access the string by giving the index number. So for example, system task name 0, that is the list object, and then you just give the first index number, which is 0. can see this here, system task, task names are all this, then you get the first one. Okay, the other way I found out you can do it, okay, I did a lot of reading and I can't remember where I read it from now. Okay, but what I do is here I have this thing called get task objects. Okay, so I do this NI-DAQmx first, and I import the system. Okay, I import the system from here. Okay, system, you see here, system equals self, NI-DAQmx system local, self.system equals to system. Then I build the system. Okay, so once I build the system, I have this task object equals to system.task, and then that's why I do it. That's where I get it. So task objects equals NI-DAQ object not get task objects. Alright, so let's print the task objects. Okay, so it's excuse me, it is actually a system collection of persisted tasks. Excuse me, it's a persisted task collection. So how do you access the individual tasks within this task object? So you just go for task in task object. Okay, 1, 2, 3, 4. Okay, print task. Okay, so immediately when you do that, you are able to print out all the 3 persisted tasks. Okay, or you can access them then by index number maybe. Task object 0 is actually persisted task, name equals to module A temperature reading. Task object 1 is persisted task, my temperature task. Task object 2 is actually persisted task, my voltage out task. Now, there is a difference between persisted task and actual like running tasks like we saw just now. Persisted tasks are like, you know, you save the task, but you haven't started running it yet. Whereas when you create a task object over here and start reading, okay, over here you actually make a task object and you start reading. Okay, the moment you read and then you close all the configurations actually disappear because you haven't saved it properly. So if you want to save it in a more permanent way, you use this thing called persisted tasks, and that's what you do by, you know, making tasks manually in the NIMax Explorer, and then you run them one at a time. Okay, so this is what persisted tasks are about, and to access it, I just showed you how to. Okay, using the system tasks. So I have this task object list, and then I have NI-DAQmx NI-DAQ object, and I get the persisted task. That's the function I just showed you. Okay, and then I ran a for loop and printed out all these task objects here. I also run a for loop here, and I'm able not just to print the persisted task. Okay, actually I print the persisted task twice. I have no idea why. Okay. Okay, the way to convert a persisted task into an actual task is to use the load button or the load function, as you can see here. Okay, this persisted task object here has a load button. So task equals to task object. Okay, this is the list. If I access the first index of this list, it will be the persisted task object, and then that persisted task object will have a load function. So I can just do it like that. Task equals task object dot load, task dot read. Okay, if I do the task dot read, it will just do this, and you can see this this thing is actually running. Okay, and then it says what? There's a DAQ error. Okay, task name actually conflicts with existing task name. Okay, so you see, if I just run this persisted task over and over again, I will get a lot of errors. So what do? I need to actually close this task first. Okay, and then let me load the task again. Task.read, and then I can read properly. So you see, okay, now this is one example of you know tasks opening and closing. All right. task opening and closing, and then there's an error of the buffer. So if you leave a continuous task collecting samples too long, you will have this buffer error thing. So yeah, depending on how, okay, what's a buffer error? Buffer is actually a temporary storage. So usually your DAQ will continuously yeah, let me go and check. Yeah, this buffer error is basically, you know, your DAQ will actually keep collecting data over and over again, and then you'll store them in a temporary storage, and this temporary storage is called a buffer. And there are reasons you have a temporary storage like a buffer. It is basically to manage the data flow over time. I'm not going to explain it now because it's going to get very long and lengthy, but yeah, basically if you leave a task running too long and collecting data too long, this temporary storage of buffer will start to fill up, and then the problem is it will have overflow, and then you have errors. Okay, so that's what happens if you so-called get too complicated a task. Okay, so instead of doing it like that, you can actually just like I said before, you can actually just execute the read function as and when you need to read a value. Okay, you just execute a read function as and when you need to do your read value, then you won't have this buffer overflow problem. If you run the read functions one at a time, so once the thing reads and then it will just throw away the data, then you will never ever need to store it in the buffer. Okay, or you can also program your own buffer, it's really up to you. But okay, I'm not going to. So yeah, what I've just gone through is why you need to close the thing, because you will have yeah, this one is the buffer error, and then here it says you'll conflict with an existing task name. Okay, so if it conflicts with the existing task name, you need to close the thing first, which will delete the whole task, and then you can load it up again. Okay, under the same name. Okay, so that's why it's always a good practice to close. So you can see here I have a task close here. Alright, so so loading using the load function from a persisted task object will be able to give you the proper task, and then you can start using all the read functions. So what I do here is, if the task name is my temperature task, then you can read the value, you print the task value, the type of the task value, and you print the task value. So these are just basically floats or strings that you can take a look at. So yeah, let me test read existing tasks. Yeah, so yeah, so this is what this part is doing. Okay, that is the module 8 temperature reading. So that is what this output is here. Next thing is oh, sorry, it is supposed to be this part. Okay, this part is my temperature task over here. So these two highlights, this is the code and this is the output. So module 8 temperature, let me see. Yeah, module A temperature reading. So remember, we actually cycle through each of the persisted task objects. So since the first task is actually called my temperature task, your first task is actually called my temperature task, this part of the code will execute along with everything else in this for loop, and then this will be the output. Okay, you have the value and the type, and this is a class of a float. Then the second item is actually, or rather the first item is actually module A temperature reading. So this if loop actually executes. The second item is called my temperature task. Okay, so this loop executes. The third task is called my voltage out task. Now, my voltage out task is actually a task in my context. In this context, it is a task that actually allows you to send voltage signals to voltage and current signals to a reader or something like that. If you use the read function here, you will get an error. Alright, so that's why I do it such that, okay, I will only use the read functions if it's a if it's a task for reading, for example my temperature task and module A temperature reading. Okay, so that is one. Then my voltage out task, there are other functions that are more suitable for this, but I'm not going to talk about that in this video. Okay, so basically in this video I've talked about the importance of closing, okay, how to get persisted tasks from your system. So there are two ways. One is the official NI-DAQmx way. The second is through just loading the task from the system from the system object. Okay, you can just load the task from the system object, but then you will need to index it one at a time in order to get all the objects out. Okay, so that's what we need to do. Okay, if you want to know more, you have to sort of read the source code and debug, and that's what I did. But I've already done that, so I'm going to shorten the thing and then I'll just give you the answer straight. Okay, so hopefully this was helpful in helping you to understand a little bit more about what are tasks and persisted tasks and how to have proper readings from simulated DAQs. Okay, so that's all. It's a very, very rough explanation, but hopefully some rough explanation is better than no explanation. Yeah. Okay, so that's enough. Thanks for watching.